For my problem today, I'll be discussing 2016 question number 4, which is a non-calculator problem. And the question is that it's asked to consider the differential equation of dy over dx equals y squared over x minus y. I'll be covering the topics, the questions, and the score guidelines. So for our first problem, it says that on the axis provided, sketch a slope field for the given differential equation at the 6 points indicated. And the 6 points indicated are 0, 0, 0, 1, 0, 2, 2, 0, 2, 1, 2, 2. And so to get started, I'd say to help me solve it that dy over dx is equal to m, or the slope. This helps me basically just solve it. And so if we want to solve a point, like let's just say 0, comma 2, we would say that 2 squared over 0 minus 1 would give us a negative 4. So this gives us an almost vertical slope like that. And it's in negative. And if you want to solve 2 comma 2, it would just be 2 squared over 2 minus 1, which would give us positive 4. And trying to solve for 1 now, or 0 comma 1, it would just be 1 squared over 0 minus 1, and this would be um, negative 1. So this is like at a 45-degree angle. And based on that, like when you solve it, you find that this will be symmetrical because the only thing that shifts is the x would now is equal to 2 instead of 0. That's the only real difference. So you just get 2 minus 1, which would be 1 squared over 1, which would just give you 1. And for these two last ones, you know that the y value is 0. So anything 0 squared, anything, it'll give you just 0 over 0 minus 1 or 2 minus 1, but they're both equal to 0. So these are going to be horizontal lines. And the IP's guide scoring says that these two bottom slopes are equal to 1 point, and these 2 points are or these 4 values are actually equal to 1 point. These two are 1 point. So this problem is worth 2 points total. So for this next question, part B, it says, let y equals f of x be the particular solution to the given differential equation with the initial condition f of 2 equals 3. Write an equation for the tangent line to the graph of y equals f of x at x equals 2 and use your equation to approximate f of 2.1. So basically, in order to solve it, I would say that I would plug in values. So f of 2 equals 3, you can just plug directly into this original equation, and you would get that 3 squared over 2 minus 1 is equal to 9. This is our m value or slope for the y equals mx plus b. So you'd say y equals 9x plus b, and by trying to solve for b, you plug in back the y value and the x value, so that 3 is equal to 9 times 2 plus b. Solving for b, you get 3 equals 18 plus b, and that b is equal to negative 15. So now we have the equation y equals 9x minus 15. So now what we want to do is solve for the approximation of f of 2.1. So you just say that y equals 9 times 2.1 minus 15. This is equal to 18.9 minus 15 will give you 3.9. So our answer for this, 3.9. And the scoring for this is that getting this equation is worth 1 point. And this value, the 3.9, is also worth 1 point. So this part B is worth 2 points. So for this final problem, it says to find the particular solution y equals f of x to the given differential equation with the initial condition of f of 2 equals 3. So first I would just separate the variables and solve to say dy equals y, or dy over y squared is equal to x minus uh, 1 over x dx. And then when you take the integral of both sides, you would get that the left side is negative 1 over y is equal to um, ln of x minus 1 plus c. So now what I would do is probably solve for c, which is easier here. You would say that given we have f of 2 equals 3, so we have negative 1 over 3 is equal to ln of 2 minus 1 plus c. And we know that this will be the ln of 1, which is 0, so we'd get negative 1/3 is equal to c. So we can now write the equation negative 1 over y is equal to ln of absolute value of x minus 1 minus 1/3. And then when you multiply the negative over and divide the right side and move the y over, you would get that y is equal to negative 1 over ln of x minus 1, all in absolute values, minus 1/3. So this is our final answer. And so the scoring for this is that if you separate the variables, this is worth 1 point. That if you correctly take the antiderivative and get to this step, so taking the integral, this is worth 2 points. This is worth 1. You get 1 point for making sure to include the c value and solve for the c, and then so these two steps combined is 1 point, and then this final answer is worth 1 point. And so this problem total is worth 5 points. So 3, 4, 5. And there's a bit of notes that it has in the scoring guideline. It tells you that you will only get the first 3 points if you don't have C in it, so they'll stop grading after C even if you end up solving correctly. And that if you don't separate the variables initially, you won't get any points. And it tells you that the solution is valid for for plus e. So for x is greater than 1 and less than 1 plus e to the 1/3 power, but it tells you that in generally you don't need this, you don't need to mention this. It's that's not what they're asking for. If they were, they would let you know. So, and that is how you solve the 2016 number 4 and its scoring guideline.